Hello everyone! Welcome back again to my YouTube channel. It's always been your host, SHERLINA A. AGCOPRA. Today, we will discuss topic on equations transformable to quadratic equations, including rational algebraic expression. Equation rather. Okay? So sit back, relax, and enjoy with the math. Of course, with the host. Again, our lesson is all about equations transformable into quadratic equations, including rational algebraic equation. By yours truly, SHERLINA A. AGCOPRA. Next, let's have an example of rational equations. So these are the examples of rational equations. Like in A, we have x plus 6 over x equals negative 5. In here, you can see a fractional term of the equation. So therefore, this is a rational equation. And B, we have here also a fractional form. Then it can be considered as rational equation. For C, we have 1 over x plus 2 minus 1 over x minus 2 equals 1. This is also fractional. So in our definition of rational equation, at least you have one fractional form. So therefore, C is also a rational equation. Same thing in letter D. This is a fractional form, also this one. So that is, these are now an example of rational equations. Okay? Can you see now what the examples of rational equation, and can you just easily identify if the equation is rational or not? Of course, yes. As I said, it's an equation with at least one fractional form. Okay? Now, let's move on to illustrative example 3. Now, the given equation is also in rational equation form because this is fractional and this one. So we have to find first the common denominator or the LCM, least common multiple. Since the denominator from the equations are 1 and y minus 2 from here, taken from here, this is over 1 and the denominator of this fraction. Therefore, the common denominator is y minus 2. And then multiply it both sides of the equation, the left and the right sides of the equation. Then simplify. You have this, y times y equals y squared, y minus y times negative 2, you have this, and plus 8. And then y minus from here, minus 2, y minus 2 from here, and then plus 4y. And then combine like terms and arrange it to standard form. So we have now a quadratic equation in standard form. It's y squared minus 7y plus 10 equals 0, where our a is 1, b is negative 7, and c is 10. And then getting the solutions of the transformed equation, you have to use factoring because it's easy for us to factor, no? To use factoring in these quadratic equations. So, and then equate it, all each factors here equated to 0, you got y is equal to 5 and y is equal to 2. From here. Remember that A times C is equal to 1 times 10 equals 10. And the factors, the factors of 10 is equal to negative 5 and negative 2. And then the sum of these factors here is the numerical coefficient of y, 7, negative 7. So our y sub 1 is 5 and our y sub 2 is positive 2. So the solutions of the equations are y is equal to 2 and is equal to 5. These values of x make the equation, this part here, or from the original here, is true. So how do you know that one of the factors of, or rather one of the solutions of this equation here is true or extraneous solution? Of course, by checking. So you have to substitute the value of y in the original equation, 5 and 2. If the statement is true, then the left side of the equation and the right side of the equations are equal. But if not, it is an extraneous solution. Okay? So let us check. Now let us check for the value of y substituted in the original equation. So after substituted the value of y, which is 5, to the original equation, you come up with the left sides of the equation is equal to the right side. Therefore, the value of y, which is 5, is true from here. Okay? So 23 over 3 is equal to 23 over 3. So the value of 5 for y is true. Because the left and the right sides of the equations are equal. Okay, what about when y is equal to 2? 2 is substituted here to the original equation and you come up with undefined value for 8 over 0. So observe that y is equal to 2. The value of 8 over y minus 2 is undefined or does not exist. So the same true with 4y over y minus 2. Since y equals 2 is an extraneous root or solution of the equation, y plus 8 over y minus 2 is equal to 1 plus y over y minus 2. So an extraneous root or solution is a solution of an equation derived from the original equation. However, it is not a solution of the original equation. You can see it here that this is 0, so 2 is not equal to 1. Therefore, it is not a solution, or we call it extraneous root or extraneous solution. Okay? Can you see the difference? So therefore, 5 is a root and 2 is not, or extraneous root. Okay? I hope you understand. Yes! We're done. Thank you for listening. Hope you learned something from it. Okay? So bye! But don't forget to like and subscribe my channel. Okay? God bless!